Hello, good morning. I appreciate that you guys are patient with me because I do have to go to Farmington today to the endodontist. It's going to be a lot of fun. And so I'm recording this early so that, anyway, since we're not having a Google Meet. So, yesterday we talked about hypothesis testing and just kind of what it's about. So, just a quick review. Remember, it's based on a claim that is made about a parameter. So, whether it's like, I believe that the true percent of blue M&Ms is 30%, or whatever it is, okay, or anyway, whatever the claim is. So you claim something and then you are going to test that claim. And then you do a random sample. You look at how likely that sample is to occur. And based on the probability of that sample occurring, then gives you evidence to either reject that claim or you fail to reject the claim. So yesterday we mainly talked about percents, problems that had percent. So we looked at EV percent and SE percent. There was the number 3 on the assignment that involved averages, but please know that it's the exact same thing. It's just instead of finding EV percent and SE percent, then you're going to find EV average and SE average. So I'm going to go through one that is an average problem so that you know what they look like, but then you can also see how they're very similar. So we have a manufacturer of light bulbs, and they claim that their bulb lasts an average of 500 hours, give or take 20 hours. So then a consumer organization, they want to test this claim. So they obtain 40 randomly selected light bulbs and find out that the average lifetime was 487 hours. So is there evidence that the average lifetime is below 500? So there's some key words here or numbers that we want to look at, right? So a manufacturer claims that their average of 500 hours with an SD of 20 hours. So that is their claim, which means that's the parameter we're looking at, okay? So that means the null hypothesis will be based off of that claim. And then what they do is they sample 40 light bulbs, right? And they find the average is really 487. So that's the statistic because it came from the sample of 40. Okay, so this is the parameter, and this is the statistic. Okay, and then right here, is there evidence that the average lifetime is below 500? Now that's going to be helpful when we write the alternative hypothesis in just a second. So first, remember, the null is always, there is no difference between two things, which we'll actually learn next week, or something just equals something. Like it has to be equality, okay? So the null is always something is equal to something, okay? It's never less than, greater than, or not equal to. It has to be equal. So the null, which I told you the abbreviation, or I can't even think, is H sub O, which is the HO, and I'll tell you a funny story when we get to the p-value about that. But anyway, so the null is the average hours for this light bulb, because it's saying this particular light bulb, whoever that manufacturer is, right? Sorry, you can't even tell that's I'm sorry for my sloppy handwriting. It's really hard to talk and write neatly. Anyway, okay, so the null is that the average hours for this light bulb is 500, or I could put equals 500, right? That's my equality right there. So then the alternative, which is also denoted as H sub A, the HA, is, and this is where I can put the ditto marks, the average hours for this light bulb is what? Well, what are they wanting to test, that it's less than that, greater than that, or just not equal to 500? Well, the question says is below. So there's your key word right there. Your alternative is going to be less than 500 hours, okay? All right. So there's the null and alternative, which is step 1 that you have in your notes, right? Or at least I hope so. Okay, so now to find the z-score or the test statistic, we need to find 3 things out. We need to find, well, what's the observed average? Well, that comes from the sample. So that's the statistic right there, at 487. That's what they observed from their sample. Okay, well, what is the EV average? What can we expect? Well, that will always be tied to the null hypothesis, because that's what the parameter is, or what they claim about the population, okay? So EV average is 500. And then the SE average, the nice thing about average problems is they are already tell you the SD, so you don't have to do the SD shortcut. So we are just going to take that SD of 20 and then divide it by the square root of our sample size, because this is just for one light bulb, right? SD of 20 is for one. So when we take a sample of 40, then the standard error is going to change, because we have to take the SD of one light bulb and divide it by the square root of our sample size. So I don't have that. Hold on. So 20 divided by, oh my goodness. Sorry. You know, it just wouldn't be a fun video if I didn't make tons of mistakes. Okay, so 3.16. All right, so now we can find our z-score by doing exactly what we did yesterday. It was the observed percent yesterday, but today we're going to do observed average. So observed average, which is 47, minus expected average, which is 500, divided by SE average. So that's going to be what? Negative 13 divided by 3.16. So negative 13, I don't even need the negative, but whatever, 3.16. So negative 4.11. So I want you to think to yourself, what does a z-score of negative 4, like, is that extremely unusual? So while you're thinking, I'm going to change the color here. What color should we do? Let's do blue. Okay, so then if we're thinking of the normal curve, you guys, I didn't do too bad on that one. Okay, and think of the standard normal curve, which has a mean of 0, mean of 0 and an SD of 1, right? So this would be negative 3. This would be positive 3, okay? So if my z-score is 4 below what we expect, or 4 below the mean, that's clear over here. So hopefully when I asked you that question to think about it, you said very, very unlikely. Because outside 2 SDs is unlikely, 3 is very unlikely, and it just gets anyway, so now before we even plug this into menu 652 to find the percent, you should be thinking, okay, this can be a small percentage. The p-value should be small because this is very unlikely to happen, right? It's unlikely that we observe a sample average of 487 hours in that sample of 40 light bulbs. Okay, so now, oh, come on, being slow. Okay, so now we're going to do norm CDF, right? And since this is negative, then my lower bound will be that negative number. My upper bound will be my negative z-score. And then the mean stays 0 and the SD stays 1 since we found the z-score. Okay, so let's just find out what's this probability, how small or how unlikely it is to happen. So menu 652, we leave that, and then we do negative 4.11, leave that. Okay. See, it's very unlikely, but if we multiply that by 100, it'll be what? 0.002%. So very unlikely to happen. So therefore, we have strong evidence, because it's so small, that we are going to reject. And this is where my joke about the the null is, we refer to as the hoe just for fun, because you gotta have fun, right? So then we're definitely going to reject the hoe. I'm just laughing to myself. This is awkward, but so we're going to reject the null or the hoe, and we have evidence. So now, today, I want you to actually make a conclusion in the context of the problem, because that's the whole point of this. Like, if you just end with, oh, we're going to reject or fail to reject, I think sometimes we don't even know what the heck that means. Like, what did we just have evidence for? And that defeats the whole purpose of doing a hypothesis test. So we have evidence that now, if I reject the null, then that means we have evidence for the alternative, because I'm rejecting the null, right? So then I can just restate the alternative. I can just say we have evidence that, and then I'll just restate the average hours for this light bulb is less than 500. Is L, come on, is less than 500 hours. And ta-da. And like I said, the smaller the p-value, the more evidence, the more it's called statistically significant our results are. Okay, it's just the strong. Yeah, because we have really good proof here that whoever makes these light bulbs, they're not being honest, right? So anyway, so hopefully that helped you. Today I would like you to, let's see, what did I do for practice today? I made it last night. That was a long time ago. Let's see. Wait. Why am I in math 3? You guys aren't math 3. They're actually learning about probability and the normal curve and z-scores, which is cool, but you guys aren't. Oh my goodness, this is so slow. Oh, okay, I'm turning off the camera. Oh, this is you guys. I think I have another thing on Canvas. Yes, I do. Now I remember. So, publish these now. I did a wave today, you know, whatever it looks like. Okay, so hypothesis test with percents and averages. That's your practice today. You can take it as many times as you need. I think what I did on this one is I actually had, okay, so I have the correct answers being available tomorrow, so that if you want to try it today, then tomorrow you can see what the correct answers are and hopefully fix any that you missed. Or if you want to email me too, I can totally help you. I just may be later in responding today because I'll be at the dentist. So hopefully that helps, and I'll upload these notes too. And then I think I will do a Q&A tomorrow during our normal class time, just if you have any questions on this, because if you don't understand this from the start, it's just going to get worse from here. So please make sure you're understanding these basic ones for this week, because next week we're going to learn 2 more hypothesis tests. So tomorrow at 10:30 will be Q&A for anyone that needs it. And have a wonderful day. We'll talk to you tomorrow.